Coming up on SpaceTime, the Mars Curiosity rover faces its toughest climb yet on the red planet, discovery of the demon particle, and it's finally happened, Virgin Galactic begins regular tourist flights to the edge of space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Curiosity rover has faced its toughest climb on the red planet to date. The car-sized six-wheeled rover has been slowly moving up the lower foothills of Gale Crater's central peak, Mount Sharp. Shortly before the rover's 11th anniversary on the red planet, its team helped guide it up a very steep and slippery slope to examine meteor craters. On August the 5th this year, NASA's Curiosity notched up its 11th year on Mars by doing what it does best, studying the red planet's surface. The intrepid bot recently investigated a location nicknamed Jiao, which is pockmarked with dozens of impact craters. Scientists have rarely gotten a close-up view of so many Martian craters in the one place. The largest is estimated to be at least as long as a basketball court, although most are a lot smaller. Jiao is a pit stop for the rover's journey through the foothills of Mount Sharp. Each layer of this mountain features a different era of Mars's ancient climate, and the higher Curiosity goes, the more scientists learn about how the landscape changed over time. But it's not been an easy task. The path up the mountain over the past few months has required the most arduous climb Curiosity's ever undertaken. Now, there have been steeper climbs and riskier terrain, but the mission's never faced the trifecta of challenges posed by this slope: a sharp 23-degree incline, slippery sand, and wheel-sized rocks. This trifecta's left the rover struggling through a half-dozen drives in May and June, vexing Curiosity's drivers back on Earth. Rover driver Amy Hale from NASA's Jet Propulsion Laboratory in Pasadena, California, says it's like driving up a sand dune on a beach with the added obstacle of boulders. Hale's one of 15 rover planners. They write hundreds of lines of code designed to command the mobility system of the rover as well as its robotic arm. Now, unlike the Howard Wolowitz character of the sitcom Big Bang Theory, they don't actually operate the rover in real time using a wheel and throttle. Instead, instructions are fed to Mars the night before, and the data comes back to Earth only after the rover's completed its task. These engineers collaborate with the scientists to figure out where to direct the rover, what pictures to take, and which targets to study, using the instruments on its 2-metre-long robotic arm. But rover planners are also constantly on the lookout for hazards. They need to write commands to steer around pointy rocks and to minimise wear and tear on Curiosity's battered wheels. Geologists on the team use their field experience here on Earth to help look out for deep sand and unstable rock formations. There's even a role on the mission to gauge whether a canyon wall or a mountain could obstruct radio communications with Earth. Curiosity was never in any danger during its climb to Jiao. The team doesn't plan anything that could endanger the rover, and there are already commands uploaded to Curiosity that will stop the rover moving if it encounters any surprises. Unexpected stoppages, referred to as faults, can occur from time to time when the wheels slip too much or a wheel's raised too high by a large rock. Curiosity's strategic route planning is led by JPL's Dane Sholin. Sholin says the rover found itself in both scenarios on several occasions while on its way to Jiao. Each day when the team arrive at work, they find out whether or not they're faulted for one reason or another. Instead of continuing to struggle with the original course, Sholin and his colleagues put together a lateral detour, eyeing a spot roughly 150 metres away where the incline levels off. At least it seems to. See, the planners are relying on imagery from NASA's Mars Reconnaissance Orbiter in order to get a rough sense of what the terrain's like. But those images captured from space can't show exactly how steep the slope is or whether there are big boulders there. The detour should add just a couple of weeks to the journey to Jiao, that is, unless the terrain's holding more hidden surprises. And if that's the case, the detour may well have been for nothing, and the team's scientists will have to keep looking for another path up Mount Sharp. Fortunately, on this case, the detour paid off, and Curiosity was able to crest the slope. Since the difficult descent, Curiosity scientists have wrapped up their investigation into Joule's crater cluster. Common on Mars, crater clusters can form when a meteor breaks apart in the planet's atmosphere, or when fragments are tossed out by a larger, more distant meteoroid impact. Scientists want to understand how the relatively soft rocks of the salt-enriched terrain are affected by the way the craters formed and how they're changed over time. Despite all that Mars has thrown at Curiosity, the rover isn't slowing down. It'll soon be off again to explore another area high up on Mount Sharp. This report from NASA TV.
Here in the Mars yard, test rovers try out terrain that the actual rovers on the red planet have to deal with. Curiosity has been facing a particularly challenging last couple of months. And here to tell us all about that is rover driver Dane Sholin. Welcome, Dane.
Thanks, Marina. And that's right. The last 2 months, we've been climbing a steep part of Mount Sharp, which has been quite a challenge. The good news is our team has found a detour and we're back on track. When we made the original plan to drive over this ridge years ago, we were using orbital images, which aren't detailed enough to show us all of the hazards. It was only when Curiosity got close and took images of the area that we could see just how much of a challenge it would be. It's like the difference between Google Maps and Street View. There are 3 things that make driving on Mars hard: steep slopes, rocks, and sand, and this ridge had all 3. We tried 7 drives on the original route, but we kept slipping, and we have to be careful with Curiosity's wheels as they've already taken a lot of hits on the rough Martian terrain. We zigzagged around this area for a couple of weeks trying to make our way up the ridge, but we just weren't making any progress. We needed to try something different. Let's head to the place where we plan our routes.
From testing to actually planning the rover drives, how did you come up with a new route?
Well, there's actually a team of us that plan our routes, which can be tricky. We're essentially off-roading because there's no roads on Mars, yet. Us rover planners work with the science team members to pick our routes to get to the interesting locations while avoiding the hazards. After so many faulted drives on this particular route, we knew we needed to pull the plug and find an area nearby with lower slopes, less sand, and fewer boulders. We decided to make our way for an area 150 meters away. It was a month-long commitment to take this detour with no guarantee we wouldn't run into difficult terrain again. But at least we were moving forward. And that's life on Mars. I get to look at images of Mars every day, so I really get a sense of the landscape. I often feel like I'm standing there right next to Curiosity, looking back at just how far it has climbed. Getting Curiosity through that challenge over the last 2 months has been a huge accomplishment and so rewarding.
So where is Curiosity headed to next?
Well, we're headed back to the original route up Mount Sharp, where we recently investigated a cluster of craters. We don't see this scale of craters very frequently, so the science team wanted to check it out. Curiosity is celebrating its 11-year landiversary and is still going strong. There's something new to discover every day when you're going where no rover has gone before.
This is SpaceTime. Still to come, discovery of a demon particle. And it's taken a while, but Virgin Galactic finally begins regular tourist flights to the edge of space. All that and more still to come on SpaceTime. Back in 1956, theoretical physicist David Pines predicted that electrons in a solid can do something strange. While they normally have a mass and an electric charge, Pines hypothesized that they can combine to form a composite particle that is both massless, neutral, and does not interact with light. He named the potential particle a demon. Since then, it's been speculated that this demon particle plays an important role in the behaviors of a wide range of metals. Unfortunately, the same properties that make the demon particle interesting have also allowed it to elude detection since its prediction. But now, a team of researchers led by Peter Abamonte from the University of Illinois have finally found Pine's demon 67 years after it was first hypothesized. A report in the journal Nature says they used a non-standard experimental technique that directly excites a material's electric modes, allowing them to see demon's signature in the metal strontium ruthenate, a perovskite superconductor derived from ruthenic acid. Abermont says demons have been theoretically conjectured for a long time, but experimentalists have never studied them. In fact, Abermont and colleagues weren't even looking for it, but it turned out they were doing exactly the right thing to find it. One of the most important discoveries of condensed matter physics is that electrons lose their individuality in solids. Electric interactions make the electrons combine to form collective units. With enough energy, electrons can form composite particles called plasmons with a new charge and mass determined by the underlying electric interactions. However, the mass is usually so large that plasmons cannot form with the energies available at room temperature. Hines, however, found an exception. If a solid has electrons in more than one energy band, as many metals do, he argued that their respective plasmons can combine in an out-of-phase pattern to form newer plasmons that are massless and neutral, in other words, a demon. Now, since demons are massless, they can form with any energy, and so they may exist at all temperatures. And this led to speculation that they have important effects in the behaviour of multi-band metals. But demons' neutrality means they don't leave a signature in standard condensed matter experiments. The vast majority of experiments are done with light and they measure optical properties. But being electrically neutral means that demons don't interact with light, so a completely different kind of experiment's needed. And this is where Abamonte and colleagues come in. They were studying strontium ruthenate for an unrelated reason. The metal's similar to high-temperature superconductors without being one. Hoping to find clues as to why this phenomenon occurs in other systems, they were conducting the first survey of the metal's electronic properties. Now, scientists at Kyoto University had already synthesized high-quality samples of the metal, which Abamonte examined using momentum-resolved electron energy loss spectroscopy. A non-standard technique, it uses energy from electrons shot into a metal to directly observe the metal's features, including plasmons that form. But as the researchers began looking through the data from this experiment, they found something unusual, an electric mode with no mass. Now, at first they had no idea what it was. Demons are not in the mainstream. They did joke about the idea of a demon particle, but then they ruled it out and kept looking for other alternatives. But eventually, as they started to rule other things out, they began to suspect that they may actually have discovered a real demon. Condensed matter theorists were then asked to calculate the features of strontium ruthenate's electronic structure. Pine's prediction of demons necessitates rather specific conditions, and it wasn't at all clear as to whether strontium ruthenate had a demon. But when the authors performed the macroscopic calculation to clarify what was going on, they found a particle consisting of two electron bands oscillating out of phase with nearly equal magnitude, just as Pines had predicted. They had found their demon particle. This is SpaceTime. Still to come, Virgin Galactic finally begins regular tourism flights to the edge of space, and later in the science report, a new study shows that young people who vape are more likely to develop bronchitis. All that and more still to come on SpaceTime. Virgin Galactic has now commenced regular flights carrying tourists to the edge of space. The 90-minute flights reach over 80 kilometres in altitude, just short of the 100-kilometre high Kármán line, which marks the internationally recognised official start of space, the point where reaction systems, rather than flight surfaces, are needed to guide a vehicle. The suborbital mission, named Galactic 2, was Virgin's second commercial flight. The first, just over a month ago, carried a team of Italian Air Force flight crew to undertake a series of experiments in microgravity. The start of regular space tourism flights for the rich and famous is the culmination of a 2-decades-old dream by British billionaire Richard Branson, Virgin Galactic's founder. Passengers, paying around $500,000 each, take off from a conventional runway carried aloft aboard a winged rocket plane, the Spaceship Two, which is taken to an altitude of around 45,000 feet, mounted between the unique twin fuselages of the White Knight 2 mothership. The spaceplane is then drop-launched, falling for a few seconds before lighting up its hybrid rocket engine, which quickly accelerates the craft vertically to over 3 times the speed of sound in just 8 seconds. Once the thrust runs out, momentum continues to carry the ship to the apogee of its suborbital ballistic flight path, where passengers get to enjoy a few brief moments of weightlessness and the magnificent splendour of seeing the curvature of the Earth and the thin blue line of the planet's life-giving atmosphere against the velvet blackness of space. All too soon, however, the experience is over as the craft glides back down into the Earth's atmosphere for a conventional runway landing. So far, Virgin Galactic sold over 800 tickets, ranging in price from $250,000 at the start up to around $500,000 now. The company's main competitor in the suborbital space tourism sector is Jeff Bezos' Blue Origin, and it has quite an advantage, having already sent 31 people into space beyond the Kármán line using a conventional vertical lift rocket called New Shepard. However, that company's been temporarily grounded following the crash and burn of a New Shepard on an unmanned flight in September last year. Needless to say, they're hoping to get back into the business as soon as possible. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that young people who vape are more likely to develop bronchitis or experience shortness of breath, independently of whether they also smoke cigarettes or cannabis. The findings, reported in the journal Thorax, are based on a study of school students over 4 years, detailing their smoking and vaping habits as well as any respiratory issues. Researchers say that even when they take into account the influence of smoking, cigarettes or cannabis in addition to vaping, vaping alone was associated with a higher risk of respiratory symptoms. Well, it seems that while ChatGPT's latest versions are better at citing real scientific studies to support the advice it gives, they're still referencing a lot of fake articles as well. A report in the Journal of the American Medical Association tested the capacity of the AI chatbot to help create medical training content. The authors put both ChatGPT 3.5 and its newer version, ChatGPT 4, to the test. It asked both of them questions about learning health systems and asking them to cite journal articles to back up their claims, and then verifying as to whether or not the sources they chose were legitimate. The researchers found some 98% of the references given by ChatGPT 3.5 were fake. And even with a newer version, ChatGPT 4, it still found more than 20.6% of references were also fake. What all that means is that ChatGPT 3.5 should never be used to help create medical training content. And ChatGPT 4 should only ever be used with humans manually verifying everything it claims. Swinburne University has just launched a new $5.2 million supercomputer that'll help astronomers, medical researchers and environmental scientists across the country. The new facility, named Knowledge of the Void, will start by helping to investigate mysteries of space, including gravitational waves, black holes and galaxy formation. It'll also help study the human brain through analysis of brain data by neuroscientists, and it will analyse the planet through Earth observation data generated from satellites and other ecosystem studies. The centre's director, Professor Matthew Bales, says what used to take researchers and students weeks or even months to achieve on their desktops can now be done in just a matter of hours. Apparently, it's especially designed to help researchers facing massive data sets, like detecting gravitational waves from supermassive black holes, by performing quite literally trillions of calculations every second for weeks on end. This week on Alex on Tech, LG launches a new 27-inch portable smart TV, new warnings about sleeping with iPhones on charge, and Google improving its search results with generative AI to make the results smarter. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.live.
The pictures that LG is showing is of the TV in the back of a boot because you're having a picnic and the car's backed up, or it's sitting on a picnic table.
What's the difference between this and a good laptop?
Well, you don't normally get laptops in 27 inches. And so this is a television that is in a suitcase. So it looks like a piece of luggage. It has Dolby Atmos speakers inside, a battery that lasts for 3 hours, space for, I guess, various cables and accessories. But it's also a touch screen, basically like a giant web OS tablet. You can run different apps. You can have your Disney and Netflix and other apps. You can play a whole range of different games. It's $999 US, so it's probably going to be almost double that in Australia because our currency at the moment is lower than ever. But it's something that, do you need it? Can you watch those things or play games on your smartphone or tablet? Sure. But if you've got everything already, or you just want to have the ultimate sort of entertainment experience on the go on a device that doesn't require setting up screens like a projector or everyone to crowd around like a smartphone or a tablet, then this is your device. And it's obviously a much better viewing experience than even a 17-inch laptop.
Okay, let's move on to Apple's warning about sleeping next to your iPhone. Is it safe to charge them overnight with their lithium batteries and everything like that? I mean, we've seen what's happened to e-scooters.
Yes, look, e-scooters are normally more roughly handled than your smartphone. I mean, sure, people drop their smartphones all the time, but, we have cases that have shock absorption, and also the smartphone batteries are normally designed to charge slowly at nighttime to get to about 80%. And then over the course of a couple of hours, as you're sort of getting ready to wake up based on your normal sleep cycles, it will then charge to the 100% range. Now, what Apple is warning about is that people sleep with their phones at night and then their phone ends up underneath the pillow, under the blankets, and they're saying that having charging cables under blankets, having the phone under the blankets, there's no
ventilation,
airflow, there's no ventilation or airflow, and that in theory, because you don't hear about it very often, but in theory, it could overheat and cause a fire. And I did hear some years ago of somebody who was charging their phone and somehow got a necklace they were wearing sort of caught up in between the connections that plugged into a power board and somehow got electrocuted. But I mean, that's would be even rarer. So at Apple's website, in their important safety information, they say don't sleep on a device, power adapter or wireless charger, or place them under a blanket, pillow or your body when it's connected to a power source. And of course, when you're asleep and you're rolling around in bed, you could easily have that happen. So it's a good idea to put your phone on a MagSafe wireless charger or separately on a little bedside table. And with iOS 17, you have that standby mode if you want it, where it's showing you the time and widgets, and you can do that actually in a red light mode like the Apple Ultra Watch, so that it doesn't affect your eyesight at night with bright lights.
Let's move on to something that is smart, that is AI, and it's getting smarter. Google have been experimenting with it in their labs, and
Google has rolled out the features inside labs.google.com. It's not actually rolled out fully to the public as yet. They're testing it. They did launch it about 3 months ago and speak about it at their Google I.O., but a second set of experiences as part of their generative search experience have been launched, and these help you to see the definitions of unfamiliar terms. They also help you your understanding of coding and the different languages. They also help you to get a faster understanding of the topic at hand. And so what that means for the last one is that as you're browsing the web and you're looking at the ins and outs of a new topic, they say that they've got long and complex web pages. It's not easy to hone in on specific details. And so coming to Chrome on the desktop and also the Android and iOS apps, the generative AI can help you navigate information online and get to the core of what you're looking for even faster. And that's what Google wants to do, because it knows that if you can ask ChatGPT a question and it can just give you the answer, what do you need Google for? So Google has to preserve the search experience as we know it, but it has to enhance it. And so this is, search generative evolution whilst you're browsing. And I guess Google wants to be there with you as you search the web, just like, sidebars in your browser, just like Microsoft wants to have this sidebar in Windows that sort of is always open and always there as you're in Word or other programs, that you can cut and paste information from into the chatbot search box and sort of have it do things, have it summarize it for you or explain certain things or transcribe videos and audio for you and then allow you to export those back into what you're doing. Google wants to have that experience whilst you're on the web, because most of the time we spend on the web these days, even if we have all those other apps open. So all the companies are coming at it from different angles. And, by the end of the decade, the computing experience as we know it will be much more automated and much friendlier and much more attuned to what wants, needs and desires are. And we'll be trying to guess what we're, wanting to know next. All the details about this and other stories that I've been speaking about, it's all at techadvice.life.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.